Okay, so this was the assignment that you were supposed to have done on Friday, 1/17. And I just wanted to take a minute and check your answers and also make sure you didn't have any missing pieces and to clarify a few things up. So it's pretty simple. You had to plug these values in to graph this equation. Remember that f of x is the same as saying y, so you can always rewrite that equation as y equals 2 to the power of x. They wanted you to graph that line, so you can see that I went ahead and graphed that here, right? So that was this first equation, y equals 2 to the x right there. And this other graph comes later on. This is the intercept, and on this one happens to be a y-intercept, 0, 1, all real numbers, y greater than 0, asymptote at y equals 0. I did not draw the asymptote on there, but that's where it would be. If it's helpful to you, you can go ahead and draw that on there, but I didn't want to draw that on there because that can get confusing when you go to graph the other one. So in number 3, they said consider the function g of x. Again, that's the same as saying y equals log base 2 of x, and they wanted you to complete the table. This time they gave you different x values and you had to plug them in using what you know about logarithms to get to that answer. So if you're having trouble with this would be a good thing to ask for help on. If you have y equals log base 2 of x and you are plugging in 16 for x, that would be y equals log base 2 of 16. Remember what this is asking you. 2 to what power gives you 16? This is what you're thinking about. And that would be 4, and you can see they put that there. And you would have to keep doing that. Remember, when you see 0.25 and you're dealing with logarithms, oftentimes writing it as 1/4 when you go over to this form would actually be a lot easier. So you can see that that's what the table looks like there. It says use the values from the table to graph it, and you can see up here I have graphed. This is the y equals log base 2 of x graph there. The next thing they said is to add the line y equals x to your graph. And y equals x is the easiest line to graph. You could think of it as slope-intercept form, but I just picked a couple values for x. If x is 0, if I plug it in, y equals 0, so that's the 0.00. If x is 2, y equals 2. Plugging it in, I get 2, 2, and you can see I graphed that up here. That's what this dashed line here is. This dashed line is the line y equals x. So, and they wanted you to see, like, what do you notice about that? And so on that, you can see, in my opinion, what I see is that these two graphs are reflections of one another. So they look the same on each side. It's almost like that line is a mirror. Also, they said to look at this table and look what's going on with these values. Okay, this table. Also look at the two tables of the points. What you can see here is that from the y-intercept, now this one down here doesn't have a y-intercept, the log equation, it has an x-intercept, right? That x-intercept is 1, 0. The domain is not all real numbers. The domain stops right here. That log function actually has an asymptote right here. I'll do that here in orange, right? It's at x equals 0. It's never, ever, ever going to cross that x equals 0. And where you have all real numbers is actually your range now. It's going to go down forever here, and then as it's going to the right, it's going to go up forever, making that all real numbers. And you can see what's basically happening here. If you look at the intercepts, the x and y's have switched places. Look at the domain and the range. They've switched, right? And instead of it being an x, it's now a y. Look at the asymptotes. The x and y have switched places. Look at your two tables. If you look at your two tables, look at the x's and the y's, look at the x's and the y's, and you'll see all that they've done is switched Like they've literally flipped. So you can see you had 4, 16. Here you have 16, 4. And that's exactly what happens when you are talking about the graph of a exponential function and its inverse function, which is the log. The x and y switch places. So this is going to help us to, and that's what you answer for number 6. And then this is going to help us to lead into this next part here. This is that just empty. But down here on this page, what you're doing here is you are graphing logarithms. So when you are graphing these logarithms, you're going to have to think about the fact that the x's and the y's switch places from a exponential function to a log function. Okay, so normally when we would graph something like y equals 3 to the x, I would tell you make a table of values using your Fab 5, right? -2 down to 2, right? But remember, now you're going to be graphing a log, and if it helps you, if you want to think about this as y equals log base 3 of x, you can. Always rewrite that if you want to, but you do not have to, okay? You have to think that from this exponential to its inverse log function, the x and y switch places. So that means when you go to graph a log, you want to actually create a table of values, but instead of using the Fab 5 on the x values, you're going to use the Fab 5 on the y values. So you're going to be plugging those values in. For a log, you're going to plug them in for y. You're going to plug them in for y, and you're going to figure out what x is to get your points, which then you can answer all of these questions. So I'm going to do the first one with you and then let you try the rest on your own. So plugging -2 in for y, that's in place of f of x. You're going to have -2 equals log base 3 of x. And so on this equation, this is in log form, and I've told you before, if it's in log form and you can't figure out this number, think about it in exponential form, right? I know that my log is written on the other side. You can flip this around. If you like to read your logs with the log first, just use a little bit of symmetric property and flip it around if that helps you. We have talked about how if you have log of a base of a number equal to a power, that I can change that to exponential by doing base to the power equals that number. That should also be written on the board somewhere that you can reference if needed. This is a conversion you should be able to do in both ways, but for these particular problems, we're going to want to go to exponential so that we can solve for that x and get our ordered pair. So remember, what's my base? 3. What's my power? -2, because what do logs equal? They equal powers, and that's going to give you your value of x. So you would do 3 to the -2, and since we're graphing, just put that into your calculator, and you can go to the calculator here, and you can do 3, press the power button, 2, make it negative, press equals, and you get 0.1 repeating. So I can go ahead and just write 0.1 in my table. If you want to write 0.11, go for it. It doesn't really matter. But you can see now I have the ordered pair, 0.11 -2, which is going to be somewhere right here. Okay, and so then please go ahead and pause this video, and I want you to do this idea, right, on the rest of these. So go ahead and give those a try. Okay, so you could have plugged these in, and hopefully that you get for these values, you should have had a 0.33, this was 1, this was 3, this was 9. Okay, plugging those in, that's what you should have gotten for each of the numbers. And remember, to do that, you're going to have to think about this exponential form to get to that answer. Whether it's on the page, get some scratch paper, figure it out if you can't do it in your head. Okay, because you can't just plug this log into the calculator and get that answer. You cannot do that. Okay, so after you graph those, let's see, we got a 0.33, -1. I have a 1, 0. I have 1, 2, 3, 1. And then I have 9, 1, 2. There it is. Okay, so the way that the asymptote works on these log functions is, well, it's the opposite of the exponentials. The exponentials were a horizontal line. These are a vertical line. This is an asymptote of x equals 0. And you can see that instead of a y-intercept, it actually has an x-intercept. That's at the point 1, 0. This graph is going to go, as it's going down, it's going to get really, really close to that asymptote, but it's going to go down forever. As it goes up, it's going out here to the right, and it is going to go to the right forever, but it's also going to go up forever. So this graph is going down forever, and it's going up forever. So when you go over to your domain and range, it's going to be opposite of what we're used to with these exponentials over here. My domain, my x values, they never get to 0, but they get really close. So we say x is greater than 0. For the range is going to go down forever. As it's going this way, it's also going up forever. Since it's going forever in both directions, your range is going to be all real numbers. So there is the graph of f of x equals log base 3 of x. There is another example here that you can try, or your teacher can try with you as well. And there's a couple more examples on the other side of the page. So I hope this helps, and best of luck with your practice.